right, we're going to go to an inner city park, and it's in the shape of a square. Oh, watch this. Oh, beautiful. Okay, and it's 300 feet on every side, because remember, all the sides are the same in a square. What you might not know is that all the angles are right angles, and we're going to talk more about that. Right angles means 90-degree angle. We talked a little bit about that when we talked about a right triangle, which meant that it stands straight up, perpendicular. We called it perpendicular to the ground. Okay, so there's a right angle there. Okay, anyway, a sidewalk is to be constructed along the diagonal of the square. So this is a diagonal of the square. Find the length of the sidewalk to the nearest whole foot. So this is what I want to find. This is what I know. I have 300 here, I have 300 here, and I have a right angle here. So here's what I know about just this. I know I have a right triangle. I know I have a right triangle whose two sides are 300, and I want the length of this side. I want to talk more about a right triangle before we continue with this, so you understand what's going on. You ready? Okay, here's my right triangle. I call these two sides, I call them sides, but I can also call them legs, okay? So this is a leg, this is a leg. The side opposite the right angle is called the hypotenuse. Okay? Well, I got something for you. Ready? Watch. That's a shelf. That's a shelf. That's a shelf. That's a flower pot. That's a flower pot. That's a flower pot. And this flower pot has a flower in it. What can you call that? Hypotenuse. Hypotenuse. Hypot in use. It's in. Okay, good. All right, has nothing to do with that, but I thought it was funny. Okay, here we go. So we have the leg, and we have the leg, and we have the hypotenuse. Okay, now, we can derive a little formula from this. First of all, I want to say this. All right triangles are not drawn like this. Sometimes the right triangles are drawn like this, and here's the right angle. Then the side opposite the right angle is called the hypotenuse. Okay, so this would be the hypotenuse. So don't get stuck on this particular diagram. Also, what you absolutely have to know is that the hypotenuse is the longest side in the triangle, always and forever. Okay? Now, a long time ago, when somebody was trying to locate distance and figure out how long something is, they came up with a little fact about right triangles. And this is only true in a right triangle. They found out that leg squared, if I take a leg, the length of the leg, and I square it, and I take another length of a leg, the other leg, and I square it, and I add them together, that will be equal to, that sum of the squares, will be equal to the hypotenuse squared. Oh, spelled hypotenuse wrong. Let's try that again. Hypotenuse, it's okay, I can do it. Hypotenuse squared. Now, this was too long for math people to write, right? We're lazy people, didn't want to write it. So what they did instead is they started calling these legs, and hypotenuse different letters. So they called this like letter A, called this letter B, and then called this letter C. Doesn't matter which leg you called A or B, but it's absolutely important, and in this formula you know that they have A squared plus B squared equals C squared, and we understand that C is always the hypotenuse, always, always, always. And this little formula always holds, only holds in a right triangle. Okay, there are a couple of different uses for this formula. One is the fact that we can find the missing side of a right triangle if we know the other two, so we can do this problem. But before we do it, we're going to do some other things. The other instance where we need this is somebody may say, hey, I have three sides for you of a triangle. Is it a right triangle? Because it's important to know sometimes if you have a right triangle. Okay, and the bottom line is I can figure out if I have a right triangle by putting the sides into this formula. And we're going to see those kinds of examples. So let's kind of learn more stuff until we get there. All right? So I'm going to erase this for now. I'm going to come back to it later. And I'm going to ask you, these next couple of questions are in your workbook, to square each number. To square each number means to take a number and multiply it by itself. All right, so let's square each number. So we'll take the number 5, and we'll square it, and we'll get 25. We'll take the number -5, and we'll square it. Remember to put it in parentheses. We're squaring the whole thing, and we get 25. Take the number 1, and we're really bored because we only get 1 back. Take the number 8, square it, and we get the number 64. Now, we want to try to figure out what is the reverse of squaring. Because what if I'm at the number 25, how am I going to get back to number 5? Well, one thing I can ask you is I could say, give me one, listen to this closely, give me one of the 2 equal factors. What does that mean? Well, I know 25 can be broken up into 5 times 5. And there's other factors as well, 1 and 25. But if I ask you for one of the 2 equal factors, your answer would have to be 5. So instead of saying all of that, give me one of the 2 equal factors, I can just ask it this way. You ready? I can use this symbol and say, what is the square root of 25? What is this is the reverse of squaring. The reverse of squaring is square rooting. And what that is asking you is give me one of its 2 equal factors, or what times itself is 25. And that answer is 5. Now we're going to come back to this one in a minute. 1, square root of 1. What times itself is 1? I would get 1. 64. What times itself is 64? I would get 8. Well, how am I going to get this negative 5 back? What do you think? Think about this. The only way to get the negative back is to put the negative in front of the 25, and that's the only way I could get the negative back. However, right now we don't really care much about that. We just care about this symbol, which means square root, and without anything in front of it, it means principal square root or positive square root only, because we know 5 times 5 is 25, as well as negative 5 times negative 5, but I don't want the negative 5 because of this symbol. If I asked you in words, what is the square root of 25, you're going to have to give me 5 and negative 5. Here's why. 5 times 5 is 25. Negative 5 times negative 5 is 25. But if I ask you with the symbol means principal or positive square root only. In your workbook, it kind of defines square root a little differently than I did. It talks about the fact, watch, and I'm going to write exactly what it says down because this definition is interesting. Okay, here's what this says. It says the square root of a positive number a, let's make a 25, is the positive number b, whose square is 25. So the reason that this is the answer is because 5 squared is 25. Wow. Wow. I just want to say, to take the square root, just think, what times itself is that number inside? Simple. Really simple, but that's how you can write it in algebra. Okay? What times itself is 25? It's one of 2 equal factors. So let's evaluate these following problems, okay? Evaluate means get a number answer. Remember, what times itself is the number inside? All right, let's take the square root of these numbers. The square root of 25, what times itself is 25? We did that already. That's boring. 5. What times itself is 1? We did that already. 1. What times itself is 0? 0. What times itself is 100? 10. Yes, negative 10 also times negative 10 is 100, but because of this symbol, we want the positive or principal square root only. Oh, look. Awesome. A fraction. What times itself is 1/4? Well, all you have to do is square root the top. The square root of 1 is 1. The square root of 4 is 2. 1/2. Just square root the top, square root the bottom, and you're fine. That should help you do that one. Square root of 36 is 6. Square root of 81 is 9. Okay, if you want to reduce that, you can. I kind of like it not reduced here only because it shows me exactly what's going on, but you can reduce that. I have to mark that, right? The square root of 10. What times itself is 10? I cannot think of a whole number times itself that's 10 because there's not a whole number. Let me explain this. This is not a perfect square. These are called perfect squares because there's a whole number that is a square root of it. This is not a perfect square. So the best we can do here is tell you between what 2 perfect squares 10 is, or use a calculator. We could do that. We could use a calculator to tell you what the square root of 10 is. It has a little square root symbol on it. But I'm going to first show you how you would do this. Tell you between what 2 whole numbers this lies. So let's take a look at that. Okay, ready? Square root of 10. Here's what I know. I'm going to write a couple of perfect squares on the board. You ready? 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. I can keep going forever, but, you know, I'd be here all day. So let's see if I can find the perfect square which 10 is between. Well, 10 is between 9 and 16. So the square root of 10 is between the square root of 9 and the square root of 16. But the square root of 9 is 3, and the square root of 16 is 4. So here's what I know. The square root of 10 is between 3 and 4. Think about this. Do you think it'll be closer to 3 or closer to 4? Well, look, 3 is 9, which is very close to 10, a lot closer than 16. I believe it would be very close to 3. I'm going to just take a look here. I think it's 3.1 something, but I'm not sure. So I'm going to hit 10 and the square root button, and it's 3.1622776. Ah, let me explain that. Whenever you have a number that's not a perfect square underneath the square root sign, it will always be a non-repeating, non-terminating decimal, which makes it irrational. So there's another example of irrational numbers. They're all non-repeating, non-terminating decimals, but as soon as you see a square root over a number that's not a perfect square, I know that's irrational, because that will always give me a non-repeating, non-terminating decimal. Cool, right? That was cool. All right, let's take a look at this. All this stuff just keeps coming back. That's why math is so cool. It's all related. If you really understand what's coming up, it's easy. Here we go. Ready? Is it possible for a 105 to be approximated by 9.875? They don't really want you to multiply this. I mean, you can if you want, but they really, really, really want you to think about it. Here's what I'm going to think about, okay? I know square root of 25. I'm going to continue from here. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. 11 times 11, 121. So the square root of 100 is 10. The square root of 121 is 11. Well, square root of 105 has to be bigger than 10, because the square root of 100 is 10, and that's more than 100. Any way you want to do that, you can do it, but that makes sense, right? They just want you to think about that question. They don't really want you to do it. They want you to think about it. Think of the perfect squares and just think about it. Okay? Let's take a look at an example where we can really use what we just learned before. Okay, it says, can 9, 12, and 14 be the sides of a right triangle? Okay, I'm going to draw you a right triangle. I know, it's beautiful, thank you. Okay, 9, 12, 14. Here's the deal. If you have 9, 12, 14, which one has to be here on the hypotenuse? Yes, it's 14. Why is it 14? Because we said the hypotenuse is always the longest side. So 14 has to be C, because remember, C in the Pythagorean Theorem is always the hypotenuse. Then we have 9 and 12. If this is really possible for this to be a right triangle, we know that A squared plus B squared must be C squared, because that's true in every single right triangle. Our leg squared plus our leg squared must be equal to our hypotenuse squared. Are you ready? Here we go. Plugging in. It doesn't matter where you put A and B, but you must put the longest side in C. That's absolutely imperative. 9 times 9 is 81. 12 times 12 is 144. 14 times 14 is 196. 81 plus 144 is not 196. But I'll do it for you, in case you don't believe me. It's 225. This is 225, which is not equal to 196. So the answer is no! No, this cannot be a right triangle. No, cannot be the side. Remember to answer the question. Okay? So, I know the Pythagorean Theorem. I know how to take the square root of a number. I know how to square a number. Let's take a look back at that challenge question. Okay, back at this challenge question, we're at the park. We have this. We have a right angle. We have 300 here, remember? 300 here. And this is what I'm trying to find. Ready, roll? Here we go. I'm going to do the work over here. So I'm going to get rid of that other mark. Here we go. We know that a squared plus b squared equals c squared. How do I know I need this formula? I need this formula because I need the missing side of a right triangle. Remember, this is c. I know that's c because it's opposite the right angle. 300 squared plus, oh, this is going to be fun, equals c squared. I'm just going to leave it c. I could have put it x, but I'll just leave it c. That's the side I want. 300 squared is 90,000. Okay. 90,000 plus 90,000 is 180,000 equals c squared. Well, this means what times itself will give me, right, c squared. What times itself, I have to square a number. So what number can I square that will give me 180,000? Well, that means I need the square root, the opposite of squaring. Remember when you solve equations, the opposite of squaring. What times itself will give me 180,000? I have no idea. I don't think this is a perfect square. I'm going to use our handy-dandy calculator. So here we go. I'm going to put 180,000 in here. Wow, I can't even work our hand. Here we go. 180,000 square root 424.264. It says round to the nearest whole foot. So c equals 424.2 whole foot. So that's all I need. 0.2. Okay, and this is feet. All right, whole foot means I'm going to look at the ones place. That tells me to leave it 424 feet. That's how long that sidewalk has to be. Okay, so this number squared, well, actually more than this number. Remember, it's rounded. So this number squared is approximately 180,000. Okay, and that's how you do that problem. Let's do one more problem. All right, let's take another look at a problem that's really kind of cool. Jill placed a 12-foot ladder against a building. Okay, here is my building. Okay, that's my building. How do you know it's my building? Because I just told you it was my building. It's my building. Placed a ladder against it. So if she placed a ladder against it, it's going to be diagonally on my building. Okay, this is what it says. It's a 12-foot ladder, so this is 12 feet. And it says that the ladder is 3 feet from the base of the building. So the ladder is 3 feet up from the base of my building. So this is going to be 3 feet. When you place a ladder against the building, you're going to get a right angle here. So I know that's a right triangle. Okay, I know that's the hypotenuse. I know that's one of the legs. And it says how high on the top of the building will the ladder reach. So we want to know how high this is. So we want to know the distance from here to here. So this is what we're trying to find. That is my x. That is what I'm trying to find. So here I have the hypotenuse. I have a leg. I am looking for the other leg. Pythagorean Theorem. Why do I know it's the Pythagorean Theorem? Because I have a right triangle. Got to be right. A right triangle, and I'm missing a side. So here we go. A squared plus b squared equals c squared. A is 3. B is, I have no idea. C is 12. So this is 9 plus b squared equals 144. Well, okay. I know how to solve equations. I want to get the variables on one side, numbers on the other. So I'm going to subtract 9. I'm going to subtract 9. Okay, good night. B squared equals 135. I need a number. Multiplied it by itself would give me 135. I have no idea. So I'm going to take the square. I know it's bigger than 12. No, smaller than 12, bigger than 11. Because 11 times 11 is 121. 12 times 12 is 144. Okay, let's take a look at what it is. You know what? Handy dandy calculator time. I'm glad I have this. All right. So 135 square root, and we get 11.61. Does it say? Round to the nearest tenth if necessary. So b equals 11.61, rounding to the nearest tenth. B is, since that's not a 5 or higher, we leave that alone. 11.6, is it feet? I believe it's feet. Feet! And you're done. Okay, and that's the end of the Pythagorean Theorem. You know you need the Pythagorean Theorem when you're looking for the missing side of a right triangle. Must be a right triangle. Or if you're giving 3 sides and you want to determine if it's a right triangle. Next thing we're going to look at is area.